We can make an x and y table of values, and we can plug in some numbers that we choose for x, see what it gives us for y, and that'll help us make a graph of this function. So 0 is usually a good one to plug in because that usually makes the calculation a little easier. 3 to the 0 power is 1. 1 times 2 is 2. 2 minus 1 makes 1. So we expect a dot at 0 on the x, 1 on the y-axis. So you can move your dots in Newton so you have a dot at 0, 1. Then we need another data point. So let's try plugging in 1 in for x. You can pick whatever you'd like, but 3 to the first power is 3. 3 times 2 is 6. 6 minus 1 gives us 5. So 1 on the x, 5 on the y-axis. We should have another dot. Okay, and then one thing Newton's going to look for, I think, is a horizontal asymptote. We want to think about the end behavior of this function. In other words, what happens if you plug in a billion in for x, right? And then also that's the right end behavior. And then think about what happens if you plug in negative a billion in for x. That would be the left end behavior. So if you plug in positive billion, you get an incredibly huge number, right? Which is what we're seeing here. The graph keeps going up and up and up. But if you plug in negative a billion, go ahead and try that with your calculator. It's 3. I'm going to raise it to the power of negative a billion. Invalid input. Okay, so maybe we've got to do something smaller for this calculator. For a better calculator. Yeah, let's just do negative 10,000 to get the idea. That's 6.12 times 10 to the negative 4,772nd power. That's a really, really small number. That's really close to 0. So this is getting infinitely close to 0. And then 0 times 2 is going to be 0. We have this minus 1 that always brings us down 1. So the horizontal asymptote's right here at y equals negative 1. Okay, and you'll also be able to spot that if you graph this in Desmos. If you go to desmos.com/scientific, you can type this in, use shift 6 to get the exponent symbol, and then make sure to arrow down because this isn't in the exponent. But yeah, you should be able to go to desmos.com, graph that, and you'll see the horizontal asymptote.